Now let's look at the next question. Alpha minus beta cube. Now, if you look at alpha minus beta cube, since we are having cube and we are having a minus here, we should all know that it's going to be in the expression of alpha minus beta raised to the power of 3 or raised to the power of 3 will be equivalent or equal to alpha minus beta into bracket alpha minus beta squared. Are we getting something here? So therefore, it will be alpha minus beta cube will be equivalent to alpha minus beta into bracket alpha squared minus 2 alpha beta plus beta squared. Yes or no? Okay. So therefore, alpha minus beta cube will now be equivalent to this. If alpha multiply alpha squared, we are going to be getting alpha cube. If this alpha multiply minus 2 alpha beta, I'm going to be getting minus 2 alpha squared beta. And if this alpha multiply positive beta squared, I'm going to be getting positive alpha beta squared. Now, if I take my minus beta and I use it to multiply minus alpha squared, I'm going to be getting minus beta alpha squared. If I use my minus beta to multiply minus 2 alpha beta, I'm going to be getting plus 2 alpha beta squared. And if I also have this minus beta multiplied by minus beta squared, I'm going to be getting minus beta cube, right? If you look this, alpha multiplied by alpha squared, I'm going to be getting alpha cube. Alpha multiplied by this, I'm going to be getting minus 2 alpha squared beta. And alpha multiplied by this, I'm going to be getting alpha beta squared. If I multiply minus beta with alpha squared, I'm going to be getting beta alpha squared. If I multiply this with this, I'm going to be getting 2 alpha beta squared. And if I multiply this with this, I'm going to be getting beta cube, right? So therefore, it's going to be in form of alpha minus beta cube is equals to, collect like terms, alpha cube minus beta cube. Are you getting that point? Now this is 2 alpha squared beta. Are you there? Alpha squared beta. And this is what? Alpha squared beta. If I use this to sum up this forms minus 3 alpha squared beta, right? And if I also use alpha beta squared to sum 2 alpha beta squared, this is going to be plus 2 alpha plus 3 alpha beta squared. Are we getting something here? So therefore, it's now going to be alpha minus beta raised to the power of 3 is equals to alpha cube minus beta cube. Now look at something. If this 3 and 3, I will factorize. This is a 3. Now let me factorize. Now this 3 and 3 is a common factor, right? So I'll put out 3 here, right? Now alpha and beta, let me take alpha and beta from this. Now, if I take alpha and beta from this, if I remove alpha here, I'm going to be getting alpha here, right? And here we're going to be what? If I remove beta here, so beta will be gone. If I remove alpha here, it will be gone. And if I remove beta here, there's going to be what? Beta, right? So it's now be in form of minus 3 alpha beta into bracket alpha plus beta into bracket alpha plus beta into bracket alpha plus beta. Since I'm looking for alpha cube minus beta cube, I pass this here, and therefore it will be alpha minus beta raised to the power of 3 plus 3 alpha beta into bracket alpha plus beta will be equivalent to alpha cube minus beta cube. And that will be our expression for this particular equation. Are you getting the point now? So now, let's look at another one. Let's look at something like this. Let's say we have something like this. Let's say we have 1 over alpha minus 1 plus 1 over beta minus 1. Right? Now, they're now asked us to find an expression of this. Now, the first thing you do is you find what I call the LCM. Right? Now, in the LCM here, it is the multiplication of the two denominators. And therefore, this will be alpha minus 1 and what? And beta minus 1. Right? So, if this denominator denominator, divide both of this. This will cancel out this part, right? And remain this part. So this part goes there. So this multiplied by 1 forms beta minus 1. Now, this must divide this, right? It will remain alpha minus 1. Therefore, it will be plus alpha minus 1. Now, you should notice something, right? That this will now be equivalent to beta plus alpha, right? You see the same thing as saying alpha plus beta. Alpha plus beta minus 1 equals minus 2. Alpha plus beta minus 2 into the bracket. Now, let's expand this. Alpha times beta will give me alpha beta, right? Alpha times minus 1 will give me minus alpha. Minus 1 times beta will give me minus beta. And minus 1 times 1 will give me positive 1. Are we getting something? And therefore, this is going to be in form of alpha plus beta minus 2 divided by, now, alpha beta. Now, I have minus alpha. I have minus alpha minus beta. I have minus alpha minus beta. So if I have minus alpha minus beta, I can easily just take out the negative sign and it becomes alpha plus beta. Are you getting the point now? So minus times alpha will give us minus alpha. Minus times beta also give us minus beta. It means that the negative sign is just the factor that is what? That is common. Plus 1. Plus 1. And this will be equivalent to what? To 1 over alpha minus 1 plus 1 over beta minus 1. So this is the expression that we are looking for. You can see that at the end of the day, this is still in form of alpha plus beta, alpha beta, and alpha plus beta. And therefore, we can substitute our value, knowing that alpha plus beta is minus b over a, and alpha beta is c over a. Now, let's look at another one. Let's quickly look at another one. Just for us to understand different procedures in derivation of roots of a quadratic equation. Let's say we have something like this. 1 over alpha squared plus 1 over beta squared. Are you there? 1 over alpha squared plus 1 over beta squared. We all know that what we are going to do is what? Is to find the LCM. Which is what? Alpha squared, beta squared, right? And therefore, if this divides this, becomes beta squared, while this divides this becomes alpha squared, right? And therefore, we all know that beta squared plus alpha squared is still the same thing as saying alpha squared plus beta squared, right? And we know that alpha squared, beta squared can still be saying that alpha, beta raised to the power of 2. Are you getting the point now? And we know that alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta. And therefore, this becomes alpha plus beta squared minus 2 alpha beta divided by alpha beta raised to the power of 2. And that will be my answer. Now, let's look at another one. Now, let's look at another one. Let's say we have something like this. Alpha over beta plus beta over alpha. Alpha over beta plus beta over alpha. Taking the LCM, this multiplied by this forms alpha beta, right? Now, if I take this beta to divide this, right, I'm going to be getting alpha. Alpha multiplied by alpha is what? Alpha squared. Now, if I take this alpha to divide this one will cancel, right, and remains beta, right? Beta multiplied by beta is what? Beta squared. And therefore, it's going to be in form of alpha squared plus beta squared. It's still the same thing as saying alpha plus beta squared minus 2 alpha beta. And therefore, it's going to be alpha plus beta squared minus 2 alpha beta over what? Over alpha beta. Are we getting the point here? So these are just different ways in which we can actually express our different roots of what? Of equation. Now, in our next class, we are going to be discussing various cases in which the root of a quadratic equation can be asked in exam. And I'm going to be teaching you shortcuts in knowing the expressions of all these particular formulas. God bless. See you in my next class. My name is Gosplan, and if you want more inquiries about tutorial, our numbers are 090 65 69 1826. You can text us call us or give us a DM on WhatsApp. So thank you very, very much.